one thing I didn't talk about yesterday was, you should have like a notebook dedicated to House 3 or a 3-ring binder dedicated to House 3. Either one. If it was me, I would dedicate the 3-ring binder to it, because then that way you can put your homeworks in there, and later on we're going to have graphs, and you can put your graph papers in there and things like that. But again, that's just me. I'm a different breed of cat. Okay? So, good morning. Everybody, now, for you guys it's a little easier. I just taught a class full of freshmen, so I asked the question, how did yesterday go? And they kind of looked at me like they were all freaked out, because some of them went to a long class, some of them went to class early, and, because let's be honest, if you come to, you're brand new to our schedule, little intricacies here. But everybody's day went good yesterday?
Right.
Good. Wisconsin Rapids this week, right? Yeah. There? Yeah. Okay. Who's soccer tonight? Yeah, who you got? Everest? There or here? Here? 4 o'clock? 5 o'clock? Can I play? Tennis? Now, Merrill today? Sitting it out? One of those. I can understand it, because I've never heard anything of Merrill tennis. I didn't even know if they had a team. Get it. Am I missing anything else? Anybody else in a fall sport or activity? Making that connection. All right. So let's get into it, because the quicker we get into it, the quicker we get done with it, the quicker we can, just kind of hang out and not have to worry about the maths. Yeah? So, I know this is not your first rodeo with solving linear equations. Okay? I know that. You've done it. You did it in middle school. And I know you did it in middle school because I talked to the middle school teachers. You did it for sure in Algebra 1 during the COVID year. And you actually did some of it in geometry. You for sure did it in Algebra 2. So now we're going to do it again in Algebra trace. So, if I were to, and these are all on the next slide, okay? But I want to see what you guys have in between your years. If I said solve an equation, okay? Now you could tell me how to do it. Add 4, divide by 2, like those kind of things. But in the more abstractness of it, what are some of the rules that you have to follow when solving an equation? PEMDAS? Yep. You got to follow the order of operations. Yep. Okay. What other rules? Solve. Like we want to get. We're going to have these long, ugly looking equations. We want to get them down to X. Yeah. That's the big one. That's the good one. We got to follow our order of operations. Anything else? Let's get into the mechanics that we're going to use. If I want to move something, like, if I want to, like if it's 3x plus 4 and on one side, if I want to move that 4, what do I got to do? I have to do the opposite, right? So I got to do the opposites. So addition is opposite of subtraction, multiplication is opposite again, you know this next slide has like, I think, 4 rules on it, or four hints, keys, whatever you want to call it. If you don't write them down, you don't write them, because you've done them. You do these every time that you solve an equation, okay? So some reminders here for you. Whoa, hey now. So some reminders here for you. First off is the golden rule algebra. What you do to one side of the equal sign, you got to do on the other. So if you add 4 on the left, you got to add 4 on the right to keep it in balance. Okay? If you multiply on one side, you got to multiply on the other side. Okay? If we're going to move something or do something to one side, we're going to, we want to get rid of something, we have to do the inverse. Okay? We have to use inverse operations. Answer is always in the form variable equals some number or some number equals the variable. Okay? And that's a singleton variable. Saying 2x equals 7 is not solved all the way. Okay? All right? And lastly, 30 seconds, if that, probably more like 5 seconds to check your answer, is going to save you a whole world of hurt of like, why did I get this wrong? Okay? Why did I get this wrong? Because sometimes you might miss a negative sign. It happens. It happens to me all the time. Okay? Because it's okay to make mistakes. Okay? Right? But that checking it, that finds those mistakes or sees, tells us if we did make a mistake. Okay? All right? So let's get into these. I'm going to actually do this kind of a little bit different. I'm not going to teach you anything. I'm going to kind of gauge where you're at. Try these 2. I think there's only 2 on this slide. I hope there's only 2 on this slide. Good, there's only 2 on this slide. Solve those 2. Find x. Oh, I should have worn my find x shirt. I have a shirt that says find x. It's got a picture of a triangle and x on one of the sides. And a circle that says pound it. So for me, and again, now it doesn't really matter what order you do it, if you move stuff over, all that fun stuff, it really only matters in the end. Okay? So that very last line is the only thing that matters. Okay? How you get to your destination is totally up to you. Sometimes I like taking the scenic route. Okay? Sometimes I like getting there and like going as quick as I can. Okay? Again, doesn't matter how you get there, it matters that you get there. Okay? So for me, on this one, I would subtract 9. Now if I subtract 9, then that's going to give me negative 4x still on the left side and negative 32 on the right side. Then if I divide both sides by negative 4, that's going to give me a final answer, because it's going to be only x left over there, equals 8. Okay? And then a quick check, again, only like a 30-second check. 4 times 8 is 32. 9 minus 32 is negative 23. That is our answer. Now, also, because we are a show work kind of class, okay, that means you got to kind of like distinguish your answer so that you know where your answer lies. Okay, so on homeworks and stuff like that, if there's not an answer space, distinguish your answer with a box or a circle or a star or something like that. Okay? On this next one, we can kick it up a notch. We can add x to both sides. And if you wanted to do that separately, that's fine. If you wanted to, because you guys are all experts at the math, okay, whether you know it or not, you've done it multiple times, you could combine those 2 steps into one if you want. As long as you're following the golden rule, what you're doing on one side, you're doing on the other, you can do that. And then that would become 8x on the left, and this would become 18 on the right. Then we can divide both sides by 8.
and that's going to give me x equals, now 8 doesn't go into 18. Would leave us with a decimal. But we're not a decimal kind of class. We're a fraction. I know you can throw stuff at me later. Okay? But we're a fraction kind of class because it's easier. Okay? Because 8 over 18, both are even, both can be divided by 2. 18 divided by 2 is 9. Divided by 2 is 4. So this is just 9/4. And it's done, and it's clean, and it's pretty, and I don't have to answer the question. You don't have to ask the question. You don't have to wonder, what do I have to round to? Okay? Because it's nice, it's clean, and it's exact. Like that? And a little up right there. Any questions on that? Love it. Roll. Let's kick it up a notch. Let's add in some fractions. Woo! This is where we go downhill? We're okay. Make mistakes. We're okay with making mistakes. Remember. Okay? Try these. So here in C, I would first subtract the 9. And then that's going to give me negative 4/5 x equals negative 41. Okay. Now I've got a couple of options. Okay. I could multiply both sides by 5. That would get rid of the fraction. Then I could divide both sides by negative 4. That would get rid of the coefficient. Or I can combine those into 1, and I can multiply both sides by the reciprocal of negative 5/4. Okay. Because on this,
multiply by negative 0.8.
I mean, you could, but again, why would you get it out of fraction form? Decimals are just not good. You wouldn't be able to multiply it by negative 0.8. You'd have to divide it by negative 0.8. Yeah. So then on this side, on the left side here, because the 5 is on top and the 5 is on the bottom, those cross each other out. The negative crosses out the negative, and the 4 crosses out the 4. So the only thing that I'm left with over here is x, what I want. Okay. Now I go to the right side, and I got to remember, how do I multiply fractions? Anybody remember multiplying fractions? Not cross. Somebody said over here. Straight across. Yep, I multiply straight across because then this is like negative 41 over 1. So negative 41 times negative 5 is 205. 1 times 4 is 4.
This
205 over 4.
I got 51 and 1/4.
That would be 51 and 1/4. Yep. I'd be okay with it. I don't necessarily prefer it, but I'd be okay with it. Because this is cleaner when you're writing it, because it's not a number in a mix-up number. In D, I'm going to show you a different method. Again, there's multiple ways of doing it. I could find a common denominator, okay? And I could combine the x terms, because when I'm adding or subtracting fractions, I got to have a common denominator. I could do that, okay? But probably the easiest way for you to do this is to say, okay, 3 and 5 both go into 15. So if I multiply both sides by 15, okay, so this 15 would get multiplied here, and it would be multiplied there. 15 times 2 is 30, divided by 3 is 10. So that's just 10x. 15 times 3 is 45. 45 divided by 5 is 9. So then that's minus 9x. 15 times 4 is 6. Now, bigger numbers. Get it? Don't like a calculator. Okay? Because calculators just slow you down sometimes. Okay? Because you could also do this. 15 divided by 3 is 5. That's smaller numbers. That's one you probably know. 5 times 2 is 10. 15 divided by 5 is 3 times 3 is 9. So on and so forth. And so then you just get here that x is 60. Works the same. Sometimes we're going to have decimals because not everybody buys into Linzmeyer's no decimal rule. Okay? 0.6g equals 2.4. Then divide by 0.6. And we get g here is good on that? Good times. Okay? Now, we've got two special situations. So let's do this. Let's do one at a time. We'll work with one special situation at a time. Okay? So on this left one, if you were to go about trying to solve it, what would you do first? Distribute the 5? Okay. All right. So if I distribute this 5, what do I get? 5x minus 20. I love it. Hold on. Okay. Now what would you do next? Subtract 5x from both sides to move one of them to the other side. Yeah. Okay. Then that gives me negative 20 equals 12. Why?
Because negative 20.
Not just because I have no x's left. No, because
Negative 20 isn't.
negative 20 doesn't equal 12. Because that's a false statement right here. It is no solution. That one's good. That one's good. Okay. Go over here into special situation number 2. Again, you'd probably start with distributing. While at the same time, you could probably combine combine. Now, if we move the 5x, if I add 5x to both sides, then that's going to give me 10 equals 10. That's a true statement now. Okay. So what would my answer be here? Infinite solutions, okay, would be one. All real numbers would be the other. Yep. Now, you guys know the symbol for all real numbers? It's the funky R. Yeah. Thank you. It's that funky double vertical R. Okay. And technically, no solution. I would also accept that. Okay, no solution is a 0 with a line through it. Not 0. Okay? You can't just put 0 there because 0 is a number that would be a solution. Okay? So that's why I don't necessarily like this symbol, because if you forget that slash, it's a whole different ball. Okay? Yes. We will have our old pal word problems. You just got it. I mean, it's just what it is, because this at the tech, this is called college algebra with applications. And anytime you see that with application, that's word problems, because that means we got to get into the real world. Okay? All right? I think I only put one on here. Oh, no, I did. I put 2 on there. Oh, maybe we'll only do 1. We'll see. Okay? So John rents a sale. First thing on a word problem. Biggest spot that people make a mistake on, other than having their phones out during the middle of class. Yeah, quick, get on the calculator.
I was trying to buy myself off my phone.
Okay. You just got to read it. Okay? Reading is where most of the problems or most of the issues happen in a word problem. John rents a sailboat on vacation. Boat has a rental fee of $45 plus $7 per hour. If John is charged a total of $101, how many hours does he rent the sailboat? Okay. So you go to the rental place, and even just you saying, I would like to rent a sailboat, that's $45. Okay. So if I was making an equation, which you should make an equation for all of them. So let's say, what do you want to go with as a variable? X. Okay. So X is going to be what? What are we trying to find? Hours, right? So X is going to be hours. Okay. So you walk up to, or you're John. John walks up to the rental counter, says, I need a sailboat. Sailboat offer, the guy working the counter says $45 right off the start. Right? Then we're going to charge you $7 per hour. So that's going to be X. And then he gets through all the stuff and he says, yep, that will be $101. So then we're going to go equals 101. First step, subtract 45. 101 minus 45 is 56. Divide by 7 gives me X is, anybody? 8. Okay. Now here's the kicker with word problems. With word problems, usually you're finding something. You're not just finding a number, you're finding a quantity of something. So the end answer here would be not just 8, it would be 8 hours. Okay. Word problems, 9.44 times out of 10 have a label attached to it. Now that label may be as simple as dollars, or it might be as complicated as widgets, or people or something like that. Okay? But they all should have a label with them. Okay? You guys want to do one more or not? You make the call. Yeah? All right, let's do one more. You try this one. Salesperson in an electronics store. Whoa, why did that go jump on me? Try that one. 26 choices. What's the variable you want to use? X? Okay, that's fine. We'll use X. What are we trying to find? So what is X going to be? Not total commission, no. Total sales that he needs, right? Okay. He's got a base salary, or the salesperson has a base salary of $10,000. So $10,000 is the minimum that salesperson is going to make every year. Okay? Then on top of that, they earn 15% on anything that they sell. 15% is not a decimal. What would the decimal be associated with 15%? 0.15. So 0.15 times how much they sell, and they want to make how much money in a year? 25,000. Yep. So we subtract off 10,000. Oops, I forgot the X. Then we divide by 0.15. So that gives me X equals, would be 100,000, isn't it? Move it over, yes, because move this over 1, 2, which means you're going to move this over 1, 2, and then so you got 5 zeros. Yep. So the salesperson needs to sell $100,000 worth of sales each year in order to make an extra $15,000. Okay. Good. That's all I got for you. You can continue working on week 1's homework if you wanted to. If you want to spend the next 10 minutes doing whatever it is you do, you got the next 10 minutes to do whatever it is you do. You get to do that hoodoo that you do. So